Okay, so we shall discuss about round robin with the interrupt architecture in this video. As we observed in the previous video with respect to round robin architecture, it didn't respond to, there was no interrupt. There was no interrupt service routine in the case of round robin architecture. Okay, so no ISR was there in the case of round robin architecture. So of course we need to have the interrupts, because any of the devices which requires the immediate attention, if it is going to interrupt the processor, then definitely that if it is going to service that device, then the efficiency increases. So that is what you have in this case, round robin with the interrupt architecture. It is just a modification that you have for the with respect to round robin architecture. If you just observe this code, we are going to discuss about just the pseudo code here. So basically it is same as the round robin architecture that you have with but the only modification that you have here is you have the interrupt service routines, different interrupt service routines you have for the different devices. As you can just observe here, you have the interrupt service routine for the device A, interrupt service routine for the device B, interrupt service routine for the device Z. So any of all the devices, they will have its own interrupt service routine. Obviously any of the devices which is going to interrupt means it will have its own interrupt service routine, because it requires the attention of the processor. Now what happens here, let us discuss about the pseudo code here, how it is going to overcome the disadvantage that you had with respect to the normal round robin architecture. As you can just observe here, this is the boolean data type which is going to declare which is going to assign like the flag of device A. For the F device A means flag of device A, of course boolean F device B. So all the devices, the flags which are going to assign to all the devices, they are assigned false here, isn't it? So because whenever the interrupt is raised, then you are going to set those flags of those devices to be true. So that is what you do it here. So first you assign all the flags of all the devices to be false here. Now the first one, as you can observe here, the interrupt service routine of the device A, whenever any of the device is going to raise an interrupt, so then you are going to set the flag of that device to be true. Take care of the input output device A. In a sense, it is not going to do any kind of action here, but is going to consider that request. So it is going to consider the request raised by the device A, so sets the flag of device A to be true. Then again it is going to handle this device B. This is the interrupt service routine for the device B. It takes care of the input output device B and sets the flag of that device B to be true. Similarly, same thing what you have it for device Z also. Now the main thing that we are going to discuss here is, this is what, as you can just observe here it is the task code. So this is what we have for the task code here. So this task code, what we are going to do here, this is while of true here. So in this infinite loop here, first what happens here is that if for example there are, let me take one a device A, another one let me take device B, another one you have it here is device C here. So in this different devices, let me actually take for the first case, you have device A here. So if device A is going to raise an interrupt, so when this is going to raise an interrupt through the IRQ pin, let me take device A is going to raise an interrupt. So when it raises an interrupt, it goes to this interrupt service routine. It takes care of input output device A, means whatever the character, whatever any of the attention that it requires, it is going to answer that call and sets the flag device A to be true. Whenever actually F device A is going to be set true, if no device raises an interrupt, then all these F device A, F device B or F device Z, all this will be false. So nothing is going to, no action is going to be taken here. So since actually device A has raised the interrupt, then F device A is set to be true here. It comes here. Now F device A is true here. It sets the F device A false. So it come to this point. Why it sets immediately that flag of device A to be false here, then handles the data to or from the input output device A. See, one thing what you have to note down here is that the action is taken here. Whatever the, if some character, the serial input output port, if it has sent some character, that character is going to be received and it's going to be put up inside the registers of the microprocessor. So some action is taken here in this task code, it handles the data to or from input output device A. Now one thing what you have to note down, the importance of setting the flag of device A to false after you answer this call of the device A. Why this has to be set? If this is not set, if f device A is not set to false here, what happens here is that when f device A is true here, it comes out of this loop, this okay, so this bracket, it comes out, it comes here, again it goes back, while f true, again f device A is true, again it handles the data to or from the input output device A, again it exits from this one, now it comes here, again it goes here, same thing keeps on repeating. It doesn't actually check for any of the other devices. So that is the problem that you have it in this code. So what has to be done here is that you have to set the corresponding flag to be false after you service that request. Okay, since A has raised the request, you are going to answer that call because f device A is said to be true in the interrupt service routine. After you come here, you set this to be false, then you handle the data to or from the input output device A. After you set the false, the big advantage here is that, just observe here, you come here, you come out of this one, you come here, then while f true, now f device A is set to false here. Now note down here, after f device A is set to false, now it is not going to check here. What is going to be checked here? F device B is going to be checked here. When it is going to check for the f device B, now it is, if B has raised the request, then it is going to be set true here. Same thing what it was done for the f device A. Now it is going to be set to true here. Again the device B is going to be serviced here. First it makes the device B to be false here. Sets a flag of device B to be false here. Handles the data to or from the input output device B. Then again it exits from the loop here. One thing what you have to understand here is that, of course, it has similarity with respect to the round robin architecture also. Why it is similar to the round robin architecture also? See here, when A device has raised the request, now B is going to be questioned here. See, f device A is said to be true here, f device flag of device A is said to false here. When it comes here, now what is going to be checked here? F device B is going to be checked here. In case B has raised the request, now f device B is set to true here, it comes here, now f device B is set to be true here. Now f device B, of course device B is going to be handled here. Now when device B is going to be handled, assume that A has raised the request again here. A has raised the request again here. When device B is going to be handled, one thing is that device B is going to be handled, device A is not going to be considered. Why device A is not going to be considered here? Because device A is set to false here. The flag of device A is set to be false here. So definitely this loop won't be executed. Okay. So device B, since it is set to true here, only this action will be considered. So that is one thing you have it here. Of course, this is one disadvantage also, because A, if it has higher priority, it can't question the, it can't actually stop the execution of the B task here. Okay, this is one disadvantage also you have it here, because A, that is what we say, A can't stop the execution of the B task here, even though A wants the attention of the microprocessor. So one by one the loop is going to be executed. See, first device A is going to be checked. Okay, if device A had interrupted, it is going to set to true here, it is going to do the service. Next, of course it is set to be false here, exits from this loop, it goes here. Again, since f device A is false here, now it is going to check for the f device B. If f device B is set to true here, now this is going to be handled here. Now this is going to be handled here. After handling of this device, now again the device B is set to false, it exits from this loop and it comes here. Now what is going to happen here? Now when it exits from this loop, okay, let me take example itself. Now first A is going to be serviced. Okay, after A is going to be serviced, now A device is set to false, exits from this loop. When it exits from this loop, if device A, before device B or device C or device Z is going to interrupt, if device A interrupts again, then definitely, because this interrupt service routine, this is one advantage that you have with respect to round robin with the interrupt architecture when compared to round robin architecture. If device A is going to interrupt again here, because f device A is again going to be set to true, definitely device A is going to be taken here. There is no doubt in that one. It handles the data to or from the input output device A. But in case A doesn't interrupt, after A gets service, B is going to interrupt. When B is going to interrupt, then device B is going to be set to true. Then it handles the data to or from the input output device B. In this case, when device B is getting service, if A tries to interrupt, this won't be considered, because even though actually f device of A is set to true here, one thing what you have to know, this will be set to true. No doubt in that one, flag of device A is set to true when B is also serviced and A interrupts the processor. Means it wants to interrupt the processor. Better way to say it like that way. It raises the interrupt request pin to be high. When it raises the interrupt request, when B is getting serviced, since this interrupt handler is getting executed parallelly, definitely f device A will be set to true here. But will it be answered? Will it stop the execution of this one and starts the execution of this device? No, because f device A is not going to be checked here, even though f device A is set to true here. Why? Because where is the action of the code? The action of the code is here. This is very important. Okay, the action of code is being done here. This line of execution, it has already passed. The line of execution is at this point, so it is never going to check for f device of A, though f device A is set to true here. See, just observe the disadvantage that you have in the round robin with the interrupt architecture. Now what happens here is that now f device B is set to, okay, when it is going to be serviced, f device B is going to set to false. Okay, let me discuss the disadvantage later. First let me go through this round robin with the interrupt architecture. Now f device B is set to false here. When f device B is set to false here, it comes out of this loop. When it comes out of this loop, now what happens? Since f device A is set to true because A has interrupted, after servicing the B interrupt, f device A is set to, of course it is set to true before the completion of the execution of the B device. F device is already set to true here. Now it will handle the data to or from the input output device A, that is A task or A device is going to be serviced. Okay, so this is one. See, one advantage that you have with the round robin with the interrupt architecture. What happens here? A is serviced first, now B is serviced first. Okay, if A again interrupts, now before the execution of the C device, now what happens is that again A is going to be taken here. Okay, A started first, after the completion of the A, B started. Now when B is going to be serviced, okay, when B is getting done, A again interrupts, but A can't stop the execution of the B device. After the completion of the execution of the B device, that is B interrupt, now since it exists from this loop, already F device is set to true, again it resumes the servicing the A interrupt here. So A is serviced twice, B is serviced one. This was not happening in the case of round robin without interrupt architecture. Why? Because if you just observe this code here, each device is handled here, isn't it? First here takes care of the input output device A if it needs service. Next one it goes here, next it goes here. It keeps on happening like that way, isn't it? So if this one, else this one, else this one, else this one, it keeps on happening like that way. Whereas in this case, what happens, since the interrupt is being raised here, since the interrupt is being raised parallelly and you have the ISR, interrupt service routine, to take care of that particular interrupt, F device A, by setting F device A to be true here, when it comes here, when it exists this one, F device A is set to be true here, then definitely it is going to be serviced here. Okay, but this is one improvement that you have with respect to round robin with the interrupt architecture when compared to normal round robin architecture. But the biggest disadvantage that you have here is, just in this case only, let me discuss. Of course, one disadvantage is that, well, any one of the tasks being serviced, no other task can preempt. That's what preemption we say. It means it can't stop the execution of the another task, and it has to wait till the task gets over, till the execution of that task gets over, it has to keep on waiting. When that is taken, when that is over, it can by actually since f device A is set to true here, it can actually resume its it can get its attention from the microprocessor. But now let me actually take this case. Now when it actually, when first A has interrupted, okay, now B has interrupted, okay, A has interrupted, now A is serviced here, now then f device A is set to false. Now after that one, it exists this one, since f device is set to false, now it will check for f device B. Now B is B has interrupted. When B has interrupted, since B is set to true here, now it will come here. Now B is getting serviced here. Okay. Now B is getting serviced here. Okay. B is getting serviced here. Again B is set to false. It comes here. Now assume that okay, before okay, after B gets over. Okay, so now what happens? Now B has interrupted. Now when B has interrupted, B is going to be serviced. After resumption of this one, now again it is going to check for f device A. If A had interrupted, then f device A, earlier only it would have got set to true, then it works. Okay, this is what we discussed in the this is same as the previous case that we discussed. Now let me take one more case. Now A has interrupted the processor, f device A is set to true. Okay, sorry, f device A is set to true. When after setting f device is set to true, this is serviced. Now it since f device is set to false, okay, f device is set to false after servicing device A. So when it is set to false, it comes out of this loop, it comes here, again it is going to execute this while after. Now assume that f device A has not interrupted. So since it has not interrupted, f device obviously it is not going to be set to true. F device A will remain false on. F device A will remain false only. So it will come out of this one. Now just take care. Let me actually take out this one. Where is the code now? The code will be at this point. The code will be at this point. Now when the code is at this point, now assume that device A, now at this point A is going to interrupt. When A is going to, again device is going to interrupt the microprocessor, it comes here. Now A is set to be, device is set to true here. Same thing, now device is set to true, but in this case B is not going to interrupt the processor. B is not going to interrupt the processor, so definitely f device B is not set to true. Now will device A be serviced at this, in this case? No, device A is not going to be serviced because the code is at this point even though f device A is set to true. Because f device B is not set to true because device B has not interrupted the processor. It will not exit from this loop and begin the service from this code. So that f device A is set to true, it should have done this one. But in this case B has not interrupted the processor, so f device B is not set to true. Now what this does? It will check for f device B. Now again it will come here. It will check for f device C. Now again if f C also has not interrupted, it will check for D, E, B, goes on like that way. So this device A has to keep on waiting. How much time it has to wait? The worst case would be checking for all the devices. First it is going to check for device B, next device C, goes on like that way. It will keep on checking for all the remaining devices, that is still device Z. So it will keep on checking for all the devices. So only after exiting from this loop, after checking for device Z also, then anyhow device A would be, that is flag of device A would be set to true. When flag of device A is set to true here, then it handles the data to or from the input output device A. So this is what happens in this case. Okay, so even though see A had been had interrupted the processor, A got serviced. Okay, after when it is going to check for the B, since f device A is set to false here, now if B had interrupted, nothing would have happened. Anyhow, B gets serviced, B is set to false, it exits this loop, it will come here, then it is going to service here. But what happens in the case if B had not interacted the processor? If B had not interacted the processor, then C also had not interacted the processor, any of the other devices had not interacted the processor, but still your program is going to check for all the different devices. It is going to check for the flags here. It is going to check for the flags of all the devices. That it consumes time. That after the when the code goes for the input output checking of the flag of device B, if A interrupts the processor, then it has to keep on waiting. The A task or the A device has to keep on waiting for the attention of the microprocessor till the completion of all the checking of all the flags of all the devices. Then it comes out of this one, then only F device is set to true. It would have got set to true earlier only, then it is going to handle the device A. So this is one big disadvantage that you have with a round robin with the interrupt architecture. One disadvantage is that any of the other, when any of the device B is getting serviced, your other device, even though it needs the attention of the microprocessor, it can't stop the execution of the device which is getting service. It has to keep on waiting. Another big disadvantage that you have is that if device A is set to true, after, of course, when device A asks the service of the microprocessor by setting the flag of device A to be true, but when the action is being taken, the F device A is set to false there. When F device A is set to false there, after it the code, the line execution of the code goes to this point, okay. So goes to the next checking of the flag. When now if the device interrupts the processor, the same device, that is A device interrupts the processor, that will not be picked, because this has to come out of this loop. It will be in the loop itself. So when it will come out of the loop, either any of the devices has to interrupt, then only it will come out of the loop, or entire checking of all the flags of all the devices that has to complete. So this is one disadvantage that you have with respect to the round robin architecture with the interrupt. And the third disadvantage, of course, no priority level. See, all the devices, they have the same priority. There is no priority level that is assigned here. It's like high priority interrupt or the low priority interrupt. High priority interrupt can preempt the low priority interrupt. So low priority has to wait for the high priority interrupt. So those all things, the priority level is not assigned to any of the devices in the case of round robin with the interrupt architecture. Just device, they are going to interrupt and then the service is being done. All the functions, the code that you have written, it is there in the one code itself. Though obviously you have different interrupt service routing for the different devices. So this is, of course, advantage is that it is definitely better than the round robin architecture, because round robin architecture doesn't take care of any of the interrupts from the various devices, but round robin with the interrupt architecture will definitely take the interrupts from the different devices, and corresponding flags are set to true. So that if you just observe here, if A is set to true here, when B is getting after A device is being serviced, when B is being serviced here, it doesn't have to wait for all the other devices to get serviced here, because when B is getting serviced, it exists from this loop. Since F device A is set to true, okay, so that will be serviced again here. So that is what we discussed earlier here. So definitely one advantage is there, whereas in the case of round robin architecture, it has to go entire loop here. After checking of this device, it has to keep on going through entire loop here, then again resume here. But there is a possibility in the case of round robin with the interrupt architecture, after it checks this device, if device B interrupts, device A is going to be serviced, then it exits this loop. Now device A is set to false. If B interrupts, definitely B is going to be serviced. Again, if in the before actually going for the device C, since now A is going to interrupt, so before the execution of the C, F device A is going to be set to true. So definitely your device A is going to be serviced. This is an advantage you have. Disadvantages, as we discussed here, so that those three disadvantages you have with the round robin with the interrupt architecture, which is going to be overcome by the function queue scheduling architecture. Okay, so but obviously this is definitely an improvement over the very simple architecture that we had, that is round robin architecture. Okay, so this is with respect to the round robin with the interrupt architecture. Okay, fine, thank you.